Today we'll be discussing about index models. In the previous class, we were explaining what is Markowitz model. And since it was a bit complex to calculate and for collection of data, a large amount of data was required in case of Markowitz model. Index models were introduced with the intention of simplifying the process of portfolio selection. So the first type of index model is single index model. It is also known as sharp index model or market model. It was developed by William F. Sharp. Now, what this model believes is that all stocks are affected by movements in the stock market. When we study the price movements of stocks, we can see that when the market moves up, the prices seem to go up, and when the market moves down, the price of most of the shares tend to decline. So, single index model is based on the notion that all stocks are affected by movements in the stock market. It is observed that there is a common response of securities to market changes. So, whenever the market changes, there is a change in the security as well. So, they are of the belief that if we study the market index, then we can understand the changes that will come in your stock price as well. So, the core movement of stocks with a market index may be studied with the help of a simple linear regression analysis. How do we do that? We can take the returns on an individual security as the dependent variable. We are taking the returns of individual security as dependent variable because the returns of individual security is dependent upon the changes that takes place in the market index. That is why it is considered as a dependent variable. And the return on the market index, the RM, is the independent variable. It is the variable which influences the returns of individual securities. So, how do we measure the security return and risk under single index model as developed by William Sharp? See, to measure the return of an individual security, the formula is alpha I plus beta I RM. That is, there are two parts to this. What is the expected return of an individual security? The first part is the alpha value, second part is the beta and the RM. The alpha component is the security's return that is independent of the market's performance. See, even if the market index value is 0, if we get a 3 value as alpha value, then it means your security is going to give you 3% return even when there is no returns from the market index. There is no particular change in the market index. So the alpha value is purely based on the securities performance, not on the market's performance. So alpha component of a securities return that is independent of the market's performance. The second part is beta value into RM. Beta is the constant that measures the expected change in RI given a change in RM. So if there is a change in the market index, to what extent is your securities return going to change? That is measured by the beta component. Now RM is the rate of return on the market index. See, suppose the beta of a security is 2, then the return of the security is expected to increase by 20% when the market return increases by 10%. If the market return is 10% and the beta value is 2, then your return for the security is going to be 20%. If the market return was 2%, then you would have had 4% as the return of the security. So whatever it is, whatever the change in the market, you're going to get double the response from your security. If it moves up by 10%, then your security's return is going to increase by 20%. If the market return goes down by 10%, then your individual securities return is going to go down by 20%. That is what the beta value shows, the responsiveness of the securities return to change in the market index. Now suppose if the beta value is 0.5 and the market return is 10%, the security return is expected to increase or decrease by 5%. So we can suggest that higher the beta value, greater the responsiveness on the part of the stock in relation to the market and vice versa. So the higher the beta value, the more your security is going to respond to changes in the market. And alpha parameter, I hope it's clear. It indicates what the return of the security would be when the market return is zero. When the market return is completely zero, what will be the return for your particular security? That is the alpha value. The alpha value can be a positive figure or a negative figure. If it is a positive one, then it is favorable to the investor. That means even if the market is earning nothing, your security is going to keep on earning that alpha values number. That is, suppose the alpha is 3, even if the market value is 0, then the security is going to earn you a 3% return. And suppose the market value is increasing to 10%, then your security is going to give you 10% plus and an additional 3%. That is the alpha value. 3% extra is going to be given to you. Now, if the alpha value is negative, it means the security will lose that much value even when the market is 0. So when you get some return from the market, your security is going to perform less. Suppose a security with an alpha value of negative 4.5% would lose 4.5% when the market return is 0 and would earn 4.5% less at all levels of market return. So the positive alpha represents a bonus return and it is highly desirable for a security, whereas a negative alpha represents a penalty to the investor and it is an undesirable aspect. So just keep in mind there are two parts to the expected return of an individual security. The first is alpha, which is completely related to the security. And second part is with regard to the responsiveness of your security to the market change. Higher the beta value, more will be the responsiveness of your security. Alpha value can be negative or positive. If it's negative, then your security is going to perform less. And if it's a positive alpha value, then your security is going to keep on giving you bonus returns. So that is how the security return is measured using single index model. Now there is also an additional part. I have not shown that in this formula. See, there's additional part. There's a plus EI, okay? E and small I. It stands for residual returns. That is, due to some other reasons which are not so frequent, you get a windfall return. And that is considered as the residual return. But most of the time, the residual return tends to be 0. That is why they have avoided from the formula. Now let's see the calculation of risk using single index model. How do we calculate risk? So to calculate risk, we have got two measures, the standard deviation as well as the variance. The variance calculates the total risk. Now, the total risk consists of the market-related risk and the specific risk. You can also say the market-related risk is known as a systematic risk and the specific risk is the unsystematic risk. This unsystematic risk, which is relating to the security concerned, can be reduced through diversification. So if your security is properly diversified, then the only risk that is going to remain is the systematic risk or the market risk. So anyway, let's see. The formula to calculate the risk of the security in case of a single index model. variance of the individual security is equal to beta coefficient of individual security, the square of the beta coefficient of the individual security into variance of the market index returns plus variance of residual returns of individual securities. So the risk consists of the risk element due to the responsiveness of your security to changes in the market index and also the variance of residual returns of individual security. Let's say the estimates will all be available. That is why we say that single index model is a bit more simple. We will look into another problem to understand why we call this method more simple than Markowitz model. I'll explain that after some time. Now let's just move on to the next part. See, measuring portfolio return and risk under single index model. How to calculate the expected return of a portfolio as well as the risk of a portfolio. So how do we calculate the return? The expected return of a portfolio may be taken as portfolio alpha plus portfolio beta times expected market return. That is, the portfolio of the return is the alpha of the portfolio plus beta of the portfolio into market returns. Now, how do we calculate the alpha of the portfolio? Portfolio alpha. Portfolio alpha is calculated by calculating the weighted average of the specific returns of individual securities. There is a proportion of investment in the securities into the alpha value of each security, and we add it up, and that is how we get the alpha portfolio. So the second part is to calculate the portfolio of the beta value. The beta value of the portfolio. So how do we calculate the portfolio beta? We'll multiply the proportion of investment in an individual security with the beta coefficient of an individual security and then take the total of all that. And that is how we calculate the portfolio beta. And the market return is also taken into consideration. It will be more clear when we work out a problem. Now, to calculate the risk of a portfolio, we'll be taking the variance into consideration. The variance is equal to the square of beta portfolio into variance of the market plus WI and variance of EI, that is the weight or the proportion of investment in individual securities into the residual returns. So let's work out a problem and it will be more clear. See, before we move on to a problem to calculate the single index model, let's see how the Sharpe single index model is more simple than the Markowitz model. Okay, so in this question, they're asking how many parameters must be estimated to analyze the risk return profile of a 50 stock portfolio. So portfolio consists of 50 securities, and they're asking if you're calculating the risk return portfolio, if you want to calculate the risk return portfolio, under Markowitz model, how many parameters are required, and under Sharpe's model, how many parameters are required. So in case of Markowitz model, we need n return estimates, n variance estimates, and n into n minus 1 by 2 covariance estimates. The total estimates that you need is 2n plus n into n minus 1 by 2. Here we know the question they have given 50. So 50 is the number of securities in our portfolio. So we are going to substitute it in the formula. 2 into 50 plus 50 into 50 minus 1 divided by 2. So you need 1325 values that you have calculated in order to find out the risk return portfolio of the security, of the portfolio. Whereas in Sharpe's single index model, we need n alpha estimates, n beta estimates, that is the number of securities. How many securities you have, you need the alpha values of those securities. The number of securities you have, you need the beta value of the securities, and residual variance estimates and market return Rm. The variance of market return is sigma square m. So the total estimates that we need is, see, 3n plus two other values, the market return and also the risk of the market, which is measured using the variance. So in case of a security with, in case of a portfolio with 50 securities, the number of calculations you need is only 152. You can determine the risk return profile of the portfolio from 152 values. So it has simplified it. It has reduced the number of values required to analyze the risk return profile of a particular security. That's why we say the Sharpe's model is a much simpler version of the Markowitz model. So there's another model also. There's a multiple index model. Now, in the multiple index model, what the researchers say is that there are other factors that influence stock price movements other than the market index, right? So there are factors like inflation, real economic growth, interest rate, exchange rates. All these elements also play a role in fluctuating the stock prices. So multi-index model attempts to identify and incorporate these non-market or extra-market factors that cause securities to move together. So what are the factors other than market which is going to influence your securities? That has also been incorporated into the multi-index model. So what are these extra market factors or non-market factors? These are a set of economic factors that account for common movement in stock process beyond that accounted for by the market index itself. I think it's stock prices. I've wrongly typed it as stock process, sorry. So that is with regard to the multiple index model. So there's only a slight variation in the formula. See, in case of returns of a single index model, we use the alpha and the beta of the market return, but in this, and the residual return also. In this case, we will calculate the beta of the non-market factor 1, non-market factor 2, non-market factor 3. So whatever factors that is affecting your security, those factors will be taken into consideration, and the beta value is also considered. That is, to what extent is your security going to respond to a certain percentage of change in that particular factor. So that is all that is studied in the multiple index model. In case of risk also, we know the formula to calculate risk in case of single index model is the beta square of the portfolio into the variance of the market. Now, if it was a multiple index model, in between these two values, there will come a beta square portfolio into variance of factor 1, beta square portfolio into variance of factor 2, beta square portfolio into variance of factor 3. Those three elements will also come in between this. Other than that, there is no other change between single index model and multiple index model. Now let's consider the question of a single index model. In our textbook, there are no questions regarding calculation as per multiple index model. We only have single index model related questions. The first question is, consider a portfolio of 4 securities with the following characteristics. There are 4 securities. They have given the proportion of investment you have made in each security, that is the weighting. Then they have given the alpha value, they have given the beta value, and they have also given the residual variance. So what are we required to do? Calculate the return and risk of the portfolio under single index model. The market return is given as 16.4, that is the RM value. And the standard deviation of return on market index is 14%. So they have given the risk and return of the market. They have given the weightage, alpha, beta value, residual values. We need to calculate the portfolio's return and risk. To calculate the return, the formula is alpha, portfolio alpha plus portfolio beta into market return. So portfolio alpha. alpha of the portfolio need to be calculated. To calculate that, we have to multiply the proportion of investment in each security with the alpha value of that concerned security. So 0.2 into 2, 0.3 into 1.7, 0.1 into negative 0.8, 0.4 into 1.2. And we are going to add all those values together, and then we'll get 1.31 as the portfolio's alpha. Now second part, we need the portfolio's beta. Same procedure, we are going to multiply the proportion of investment in each security with the beta of their concerned security. So it's 0.2 into 1.2, 0.3 into 0.8, 0.1 into 1.6 and 0.4 into 1.3, and then we are going to add all that together and we'll get 1.16 as the answer. Now the return of the market is already given in the question as 16.4. So now we can substitute the values in the formula. We'll get 1.31 plus 1.16 into 16.4. So the return of your portfolio is 20.334 as per single index model. Now we are required to calculate the portfolio risk also. The formula for the risk is given here. The beta square portfolio beta square into variance of the market plus the weight of the residual return square. So for applying this, the portfolio residual variance needs to be calculated. We do not know the second part of this formula. So to calculate that, they have given the weight 0.2 into 320, 0.3 into 450, 0.1 into 270 and 0.4 into 180, and then they have added it all together. We got the second part of the formula as 84.8. Now we need to substitute all the values. The beta portfolio has already been calculated. That is 1.16. We need to find the square as per this formula. Then we have the standard deviation value as given in the question, which is 14. The variance is nothing but the square of the standard deviation. So we are calculating 14 square plus the second part we have calculated as 84.8. And we got the value as 348.54. Now the standard deviation of the portfolio is the root value of the variance calculated, and therefore the portfolio's risk is 18.67. I hope that is clear to you. Now this is another question. So they have given 3 stocks. They have given the alpha value of each stock, the beta value of each stock, and the residual variance as well. Which single stock would an investor prefer to own from a risk-return viewpoint if the market index were expected to have a return of 15% and a variance of return of 20%? So they have given the market returns as 15% and the variance of the market as 20%. We are required to find out which one we would prefer to invest in. So we have to calculate the expected return and risk of each security. For security 1, we are not required to calculate the portfolio risk and portfolio return. In this case, we are required to calculate individual securities return and individual securities risk. So the formula is return of the individual security is equal to the alpha value plus beta value into the market returns. So the alpha value of security 1 is negative 2.1 plus the beta value 1.6 into the market return, which is 15. Likewise, we are calculating the values of the second security and the third security, and we got the values as 21.9, 7.8 and 20.7. From this, we can see that the highest return is earned by security 1. Now, before the investor makes a decision, he will take into consideration the level of risk involved also. So let's calculate the risk of the individual securities according to single index model. To calculate the risk, we need the beta square, the variance of the market, and the residual variance. So they have given the variance of the market in the question as 20%. So we know that is 20%. Beta values are given. So 1.6 into 1.6 square into 20, 0.4 into 20, 1.3 square into 20, plus the residual variance is also given 14, 8 and 18. So one by one, we'll be calculating the risk of the securities and we get the values as 65.2, 11.2 and 51.8. From this, we can see that the highest risk involved is for security 1 as well. The return is also high for security 1 as well as the risk is also high for security 1. Now we can calculate the ratio of return to risk to assess the return per unit of risk. For each unit of risk that you bear, what is the return that you're going to get? We are going to calculate that. So return by risk, that is 21.9 divided by 65.2, 7.8 divided by 11.2 and 20.7 divided by 51.8. So the return per unit of risk is 0.34 for security 1, 0.70 for security 2 and 0.40 for security 3. From this, we can understand that at first glance, even though we see that the security 1 is giving you the highest return and security 2 is giving the lowest return, when we look into it in a detail, we can see that the risk involved in security 1 is highest and the risk involved in security 2 is the least. And the percent of return you get for bearing the risk is highest in case of security 2. For a unit of risk that you bear, you're going to get 7.70 return. Whereas in case of security 1, you're going to get only 0.34. So the investor would prefer security 2 as it provides the highest return per unit of risk. So this is how you take a decision on which security to invest in by using the single index model. With that, we come to the end of our fourth module. There are other questions in the textbook with related to this. You can work it out when you have time. I hope this much is clear. Thank you.